This is Margaret Goodrich, and I also have Scott Newman on with me. Scott was the author and one of the primary lead of the task force for the 61968 standard. So I felt it was very appropriate for Scott to be included here, and he has graciously agreed. He also helped me put together this slide deck. So we are kind of joint presenters. I'm going to do the talking, and then Scott's probably going to answer your questions that you might have at the end. So what we're going to talk about is the integration patterns using the CIM. I have split the presentation into two sections. One is the enterprise integration using the 61968-100 standard. This discusses the integration implementation components that are defined in that standard. And then the second section is talking about the how you would do a successful integration using the CIM. And we're going to talk a little bit about benefits and challenges, the keys to a successful integration strategy, that kind of thing. Just to give carry this thing home, not just the technical side, but the business side as well. Okay, so the first part of it we're going to talk about is the standard itself. This standard is a standard out of Working Group 14. Working Group 14 is composed of, it is the distribution exchange standard group within the IEC, and it's composed of task forces and parts. So Part 4 is network ops, Part 8 is customer information system, Part 9 is meter reading and meter control, Part 6 is work management. So each one of those standards are designed to provide the messages that you would use to exchange data within those systems with other systems. So what we have defined within there is the use cases and the message profiles, or the message payloads for those particular standards. So when we produce those standards, a lot of the utilities and consultants actually contacted us and said, okay, well, this is wonderful and great and everything. You know, it's wonderful to have these payloads, but how do you want to use them? How would you integrate them? So in order to do that, we decided that what we needed was a companion standard that would actually provide implementation profiles, if you would, for various transports or integration strategies. So what 61968 does is provide that level of information. Now, so the purpose of this section of the presentation then is to talk about that standard. The standard is designed to have best practices for integration based on the experience of the task force. The task force for this particular part had 4 or 5, well, no, it had more like 10 people in it. I was one, and Scott Newman was the convener of that task force. So, but what we were trying to do was bring all of our expertise and our experience into the mix of how we would do an integration using the best practices for integration, and put that into the standard, and how you would use that in conjunction with the payloads from the other standards. So in addition to that, what we wanted to cover was areas of interest regarding integration. So we start off covering integration patterns. Then we talk about the various message components that you need to have in addition to payload, okay? So a payload is going to contain the data you want to exchange, but it's not necessarily going to have everything you need in there for the actual exchange to take place. So we're going to talk about the various message components. Then the message stereotypes that are available, or that you would need to do it. And transports, what kind of transports you would have. If you're using a WSDL, what would you use, strongly or generic typed WSDLs, and we'll talk about those. And then one of the things we wanted to look at was other topics that would be important to make a successful integration. There were several of them that came up, but one that was very obvious that really needed to be discussed was naming. I don't know how many of you people have, out in this audience have done integration or have played with models or data within a utility, but I've done a lot of it, and in Texas alone we have probably, I don't know, probably 200 substations, all named airport. So if you're exchanging data between two different regions of the state, you're probably going to have a substation named airport in both of them. So how do you manage the duplication? How do you manage the naming? So we actually included that in this standard as well. So with that, we will continue on. So the first thing we wanted to talk about then is integration patterns. You have a lot of integration choices. You can use ESVs. You can not use an ESV. You can use a different kind of transport. You can use queries, transactions. You can just simply exchange files. If you're dealing with, on the EMS control center side of things, the transmission side, what you really want to exchange is large models of the grid, and so those would be CIM XML files that you would exchange. There's also incremental exchanges that you would have. So lots of different implementations and methodologies that you could choose from that you want to use for the integration strategies and transfer of that data. And then there's also a very wide variety of security considerations, performance, technical. All of that has to be included whenever you put together your integration strategy. Okay, so in the Part 100, it's important to know what the scope of that is. I just said there's all kinds of strategies, right? So we want to focus then. We couldn't cover everything. If we had, we'd never get the document published. We would still be talking about it. So we had to limit the scope, clearly identify what we were going to try and do, and then say, okay, industry, here it is. We know this isn't everything. We're going to address other things later, and we're going to add to this in future revisions. But for this particular release, we're going to have our scope limited to web services, client servers, JMS, and really just JMS and web services across an ESB or not across an ESB. So obviously you can have web services that are direct interaction without any kind of integration layer. You can have JMS that goes back and forth without an integration layer. You can also have all of that operate over a message bus or some other integration layer. Okay, so first thing we want to talk about then is what integration patterns are we going to include. There's lots of them. What we decided that this standard will really concentrate on are the basic patterns: synchronous request reply, point to point, publish subscribe, asynchronous request reply, and then of course we would certainly have to support queries and transactions. So as part of our request reply. So that is the scope of the integration patterns that we wanted to cover. So in keeping with that, then we're going to look at a little bit of what those patterns are and kind of delve into it a bit. This is a basic integration pattern, the synchronous request reply and callback. These are the kinds of things you would use for any kind of remote procedure calls, basic functionality, limited technologies, things like that. You'll notice there's no ESB in between. There's no message bus of any kind. It's simply a transport between client server and using remote procedure calls. So no middleware. This is not a bad integration strategy, but it leaves some things to be desired. You certainly can't do publish subscribe with this. So we need to get past this one and get into the ones with the integration bus. Okay, so based on using an integration bus, you now can have synchronous request reply just like before, but now you have an ESB in between. Same, and you can have point to point, but you have an ESB in between. So you're going to have an enterprise service bus going between the client and the server, or the source and the target. Asynchronous request reply is the same thing. If you're talking about pub sub, publish subscribe, you're going to have a server that's going to broadcast things out across a bus, and the subscribers who have subscribed to that publication then will all receive it. So that's what this bottom is right here. You've got the server that's blasting out an event across the bus, and all the various subscribers then would receive that event simultaneously. So those are the basic patterns that we want to get into. Now, if you want to look at it from a different perspective and how this would kind of work then, if you've got basic request reply implementations, you can have that using just a web service, or you can use a JMS topic and queues and JMS interface. These web services can be either generic services or strongly typed. Later on in the presentation, I go into some detail about what is the generic versus the strongly typed web services. Then you have events. So an event might be something, for example, a meter may send out an event such as a last gas message, and that's going to go out to the AMI system, the automatic meter infrastructure system, but then it's going to go through an ESP, and you may have different event listeners. So you may have an outage management system sitting out here listening. You can have a historian sitting out here listening that's going to track that stuff and store it. The outage management system, when it hears a last gasp, it may then take on other actions and do other things across the bus to take on other actions, such as a ping to verify or to send some sort of other outage report out. So that's what's going to happen if you're just using it for events. And those can also be done, and this is really a publish and subscribe type event, because if you'll notice, it's going out to multiple subscribers of that event. This one is using a full enterprise service bus. Target services can use JMS. You can also have them using the topics and queues over here with routers in between. You can also have just straight web services coming across that bus from the service. So there's various methods that you can use and strategies that you can use for your integration. You have to pick which patterns you're going to use and when are you going to use them and how. This is another example. This is a bit more complicated, and what we have done is we've included an adapter in between. And this is key, because if you are doing CIM-based integration, the legacy system that's sending out the message and the legacy systems that are receiving the message even may not talk and may not know how to receive a CIM XML message. So you're going to have an adapter in between that would literally convert the message coming from the service and convert it into whatever it needs. So if it's coming from the client, it would convert it into what the service format needs to be, or it would, if it's coming back out, it would convert it to the CIM XML going across the bus and then feed these up here. So if your listeners or clients do not speak CIM, they'll have to have an adapter in between. Okay, so the first thing you have to do is select your integration patterns, and those were some of them that we went through just now, and those are fully defined and explained within the standard. The next thing you have to have is a common message envelope. So we went ahead and defined that. Now, inside the standards for the word group 14, the payloads will be defined within those standards, the use cases and the payloads for those standards. This common message envelope defines the rest of the message. You're going to have a header. It could be a request. It could be a reply. You will always have a header for the majority of your message stereotypes. But you may not necessarily have a payload or a request or reply. So the Part 100 defines a general approach for transport. And what we're going to want is to have a verb and a noun and a payload, okay, inside the message envelope. And within Part 100, all of them are used, all of the messages are in the form of XML schema. Okay, now the messages can be wrapped with either SOAP or WSDL or JMS. It does not make any difference. And you're still going to have all of the various types. Okay. All right. So the message example. This is an example of one where we're using a SOAP as a wrapper. So the message envelope itself is here. Message. You've got the header, payload, and here's that is the common message envelope, and then it's wrapped by a SOAP envelope. So this is what would be seen on the wire, okay? And from this perspective, you don't know whether it's using a WSDL, it's not using a WSDL, or anything else. The payload itself is going to have all different kinds of information. So if this is a meter readings message, this might have the meter ID in it, and it might have the reading type. It may have the actual reading value in it of that meter readings message. So that's how that would work. And this, in the header, you're going to create is going to contain the noun and the verb, the source, the message ID. There may be other things in here that it contains too. If it's asynchronous, there's probably going to be a correlation ID in here, which we'll talk about in a few minutes. Okay, so what kinds of verbs do you have? Well, to support queries, we have get. So you've got the get verb would take care of any queries. The create, change, cancel, delete, execute, these verbs are for transactions. The reply coming back is obviously a response to that transaction. And then the created, changed, canceled, deleted, and executed, these, you'll notice they're past tense. These verbs are for events. So if you're transmitting an event back, like a last gasp, you're going to have a created in front of it, or a changed, or a canceled. If you're doing a create meter readings message, then you would use, and that's a transaction, so you would use a create. Okay, so that's how that one works. All of this can be seen in Appendix B of the standards. So there's a lot of information about verbs and how they work. Okay, then we go a little further, and we've got the verb. The request verb obviously is get, create, change, cancel. All of these, except the get is used for queries. All the rest of them are used for transactions. The event verbs are simply the same as the transaction verbs, but they're in past tense. And all reply verbs use the verb reply. Now, I tend to like to give this out as both pictorial and then verbs, and then words. Some people like words, some people like pictures. So I do both. So this slide is simply a duplication of those last two pictures you saw. So we've got queries are indicated by the use of a get verb. So if you like words, this is your slide. And then transactions are using these verbs, and these are the valid verbs based on the Part 100 standard. Then we have the reply, and then events are past tense. Okay, so now we're into the message stereotypes. There are 4 types. There's a request message, a response message, an event message, and a fault message. If you're using a request message, you must have a header. If you're using a response message, you must have a header and a reply. In both cases, you do not need a payload. In the event message, you must have a header. You don't have to have the payload. The only one that doesn't require a header is the fault message, and that's simply because depending on what the fault is, you may not have enough information to even provide the header. All you're going to have is maybe an error code in here that has the reply. So that's how these messages are going, and you can read inside the standard. It provides lots of detail about each one of these. Each of these are applied to different integration patterns. So based on what integration pattern you choose, is going to tell you which of these kinds of messages you're going to use. So request messages will represent transactions, obviously. Response messages are responses to the query requests. And a request message may also be a query. Okay, the nouns are the actual payload. So when we say the meter readings message, the meter readings message is a noun. Okay, so create meter readings. If you want to say in-device event, that is a noun. You can say created in-device event, and now you have the noun and the verb and the noun. So the payload itself is the noun. Okay, the name of the payload is the noun. In every one of the parts of the 61968, what is contained within those is the use cases, then followed by the nouns and the payloads, and the contents of those payloads are defined based on those use cases. When I'm out in the industry doing projects, what I discover is sometimes the nouns that are the payloads that are provided within the standards and the or the contents of those payloads may not be sufficient. So we may have to extend them. We may discover that there is a payload that we need. We've got a use case for one that doesn't exist in the standard, so we have to create a new payload, which would give us a new noun. So they may be defined as needed for products and custom integration projects. So you may have new ones coming in. So the Part 100 does not go into defining the nouns. It defines the verbs. It defines the message envelopes that the noun payloads would be provided within. Okay, so an example of one. We've got an in-device event. An in-device is anything that's located at the end. Okay, so if you're sitting in the utility, an in-device would be a meter on a house because that's at the end. Okay, so it's the target of the message. So an in-device event is going to send an event. So a last gasp is an event. If you have an in-device control, that would be a power off or a disconnect message. But an in-device event might be a tamper message or, like I said, a last gasp. So in the in-device event, XSD, if you go look inside the 61970 Part 9, you will find this message. It has a resource identifier. It's got a category that is absolutely required, a created date time that is required. The rest of these items are optional. The asset itself is required so that you know what the event is about. That's always nice. And then if you have a status, the value of that status is required. So you can have a very short message here, okay, out of this. In the second and third edition, I believe category has actually changed to a different, I think this became an in-device event type or an in-device control code and for this particular one. Okay, so now we want to look at some examples of how you would use verbs and nouns together, okay, in using sequence diagrams. So you've got a load management system that sends out a get meter readings query to the meter data management system. And the meter data management system replies with the meter readings information. The load management system may also create an in-device control message to send to the load control. And this may be a power off or a disconnect or something like that, or a reconnect. And then this is going to send a reply that yes, it has received the message. It then performs the load control, and it will send an event out to the meter data management and the load management system that it has now executed that event. So this control comes in, this reply says, I got the message, I got the request, and now I'm going to actually implement that request, or I've done it. Now I'm sending out the event that says I've done it. Then we have message correlation. Now in the very first interop test, we didn't have this, and what we discovered was we needed it. We had these messages that were flying around because we did an asynchronous message, and we did like a bulk meter reading of a whole bunch of meters, and we created the meter readings request, and we sent out everything to go do that, and these meter readings were coming in at all different times. In the meantime, we'd sent out other controls and other messages, and these these messages were coming back in without a correlation ID. So we didn't know literally which message, which request this reply was coming in for. So we discovered we absolutely had to have a correlation ID. And that is set on the initial request, and then whenever it's returned, it has the same correlation ID so that the client knows, oh, this is my answer to this request. For transactions, you usually have a server that, or a subscriber that actually sends a message, goes through the bus to the server. The server sends a reply to the bus, and the bus sends that reply out to that subscriber. Now, it can also happen that the server sends back the reply. The bus now has, oh, I've got multiple subscribers that have asked for this information. So it will send that same message out to multiple subscribers. So subscriber 1, subscriber N. Every subscriber that wanted that information will be sent that message. Okay, then, so that kind of gets us through message types, message components, and all of that kind of stuff. So what do we need now for transport, okay? Well, we need to have a way to get the messages across. So that's going to be HTTP or JMS or SOAP, something like that. We had to pick, okay, there's lots of transports out there, and there's going to be new ones coming out all the time. So what we did was we said, okay, we got to get the standard out. We can't just keep editing and trying to get in everything. So we said, okay, we're going to cover HTTP, JMS, and SOAP in this version, and other transports will be added as we have a chance to do revisions. So transports such as AMQP, the XMPP, the REST, those other types of transports are not in the -100 right now. Does not mean that you shouldn't consider them. It simply means that we had to have a cutoff time to get this document out. So in future revisions, we will add, for sure, XMPP and probably REST as the next candidates. AMQP may come as well. Okay, for web services, all 61968 messages can be wrapped by a WSDL. You can have either loosely coupled, which is generic, coarse-grained. Okay, we like to use lots of different terms in our industry, so there's all three of them. Or tightly coupled, also known as strongly typed, or fine-grained WSDLs. WSDL stands for Web Service Design Language. Okay, so just to make sure that everything is going to work, please make sure that your WSDL that you create is WSI compliant and use a document wrap style, either the loose or the tightly coupled. Remember that HTTP is not the only transport out there, okay? JMS is a really good one, and the use of SOAP will allow you to wrap security around it. We do not have security in the standard. I don't know if it's going to be added. We have had requests from the utilities and some others that we need to add security for these messages. What we're hearing is NERC is saying you can't just send these messages out without any kind of security. We're not saying that you shouldn't implement security, but there's HTTPS, secure socket layer, there's encryption, there's authentication, there's lots of ways to do security, and we have not addressed that in here. We're either going to, and we're working on this right now, we're either going to do a security profile, a separate document that covers security, or we will add security into the Part 100 at some future revision. So I also wanted to go into a little bit of detail about generic versus strongly typed. We cover both types in the standard. So NXD will give you lots of information about generic. NXC will tell you all about strongly typed. We actually have used both of these types in the interop. The first and the second interop the first one only used generic. So the first and the second interop we used generic web services, and we actually used the same exact web service for a request, a response, an event, a reply message, all kinds of things, and we use them for an in-device event message, an in-device control message, a meter readings message, and that sort of thing. So, and that same generic web service worked. However, I have been to lots of facilities and lots of around the world, and looked at their integration strategy, and many places use strongly typed web services. If you're going to do that, you could actually have a web service for every noun or payload that you have. And in fact, I've been in places where they have multiple web services for each noun, depending on how that noun is going to be used or distributed across and transport, and which transport each one's going to use, and that sort of thing. You may have multiple whistles. There are trade-offs to both in terms of flexibility and specificity and that kind of thing. I will tell you that if you end up with 1,000 whistles out there that you have to maintain and you're the IT department, you better start hiring. You're going to die on the vine if you don't have enough people. So maybe you want to do some of each. Maybe you want to limit the number of strongly typed web services you have to only those things that you absolutely need that type of integration for, and use generic where possible. If you have too many of the strongly typed whistles, the more you have, the more maintenance you have. And the more you have to manage those things and remember that they're out there. So the governance on them gets to be very difficult, as well as the maintenance. Okay, so now we're down to names. This is the only topic that we tried to tackle in here. I'm not saying that there aren't other topics that we need to tackle in terms of integration, but we will do those in future editions if necessary. But for this one, we did this because we were actually implementing at a utility, and they needed to have 10 different names for their meters. And the current CIM was flat. It would only allow you to have a local name, a path name, things like that. It was a very flat implementation. We needed to really have an array of names so that we could do this. And it's not just there either within the utility. If you're talking to your ISO or you're playing in the market, you may have multiple entities that you're working with, and each entity has that meter name something different. So you need to be able to deal with multiple names. So we came up with a proposal, and we submitted it as an issue to the standards group, and this particular one went to Working Group 13 because Working Group 13 has the core of the CIM. So the common areas and the major core portions of the CIM are contained there. And we presented it to them. We had joint meetings between all the many of the working groups to work this out. It took us a couple of months, and we came up with a modeling structure for names, and that is now contained in CIM 15. And just remember that a master resource ID is just another kind of a name, okay? So this is what we ultimately came up with. You have identified object, which was always in the CIM. You have alias name. We kept that because InfoE still uses it and needed it. MRID we kept because it had been implemented in lots of different places, as was name. Let me tell you something. You start changing things that break all the implementations that are out there. The utilities are not bashful. They call you up and they tell you about it. So we really tried not to do that. I mean, I've gotten calls from them saying, what are you doing? You just broke everything. So what we do is we try and have at least some backward compatibility. So we kept identified object with these three in there, and then we added on a names class with a name in there, and a name type class, and a name type authority. Between these three classes, you actually can get uniqueness across the names. So the name is for example, M12345. name type, maybe that M12345 is a meter ID. The name type authority is the entity that is maintaining, that gave it that name and maintains that name. So in this case, maybe that is the vendor for that particular meter or something. And in this way, we could have a MAC address in here, and the name type would be MAC address, and the name type authority might be the IT department that handles the MAC addresses. So you can have an entire array of names, because you can have one-to-many, and many-to-one, and many-to-one here. So, and between, you don't have to use all three of these. You use enough that makes it sufficient to be unique. That's what you're trying to do. Okay, and how you would use this in a message. So inside any message, you can have the names class with the required name, the name type, and the name type authority. If you have a name type, you must have a name. If you have a name type authority, you must have a name. So that's the way it would look inside a message. The name type is very often optional. It should be provided by the source if there's more than one name instance is provided, obviously, so that you can get some uniqueness. And you must also remember, this does not negate the need to have bilateral mapping tables or naming services. It simply allows you to put all those names in the message, okay, which we could not do before. So an example of that bilateral agreement is you've got a message, the source sends a message related, and it's got a name of ABC, okay, so the name value would be set to ABC. The name type name would be used to specifically identify the type of name this is. When it gets to the target or the local ID, it would, maybe that name over there, ABC, is actually 1. Okay. Now, at ERCOT, we had this in spades. Okay, we had 26 members, and we had multiple territories being used by the same member because of deregulation. And so we had jointly owned units, we had jointly owned substations, we had jointly owned everything, and we would have different members would model their neighbors' grid within their model, and they would have their own names. So whenever all of this stuff would get together, the only way you could keep it straight was to have bilateral agreements. The only way you can get interoperability is bilateral agreements. So this is just one agreement. You can do this with a bilateral table, you can do it with a name service, but you're going to have to do it some way and get this taken care of so that you can address the problems. Okay. That kind of ends where what we covered in 61968-100 in terms of all of the pieces and parts that you need to do from a technical perspective to do integration. I want to now talk about the non-technical things that you need to do, which there's some technical stuff in here, but from a business perspective, what do you need to do to have a successful integration using the CIM? And I'm not sure that you shouldn't do this whether you're using the CIM or not using the CIM. I think you would have to do these things. But let's talk about what are the benefits of CIM. CIM gives you a common semantic model so that everyone in the utility, all the different areas of the utilities, will view the areas the same. So if I'm talking about a generating unit, I call it a generating unit. I don't call it a resource. I don't call it a this. I don't call it a that. Okay, so we're talking about the same terms. The CIM gives you a fully specified and allows you to get standardized XML messages for data in flight, okay, so that you can absolutely understand what those messages have in them and what they mean. It will give you some level of vendor independence and allow other vendors to come in and help, okay? But the CIM is not a panacea. It's not going to fix everything, okay? There are some challenges. A lot of legacy applications still do not speak CIM. They don't know what CIM is. So they've got their own internal serializations and formats within themselves that they still have to that you still have to deal with. So that means you have to put adapters together. Okay. You have the whole information technology, operational technology, IT, OT, culture clash. Okay. Information technology is the IT team. What they care about is being able to maintain the system, have some consistency, have some standards applied, be able to maintain operations, be able to maintain computers out there. The operational side, what they really care about more than anything else is keeping the lights on, okay? Now, I would tell you that, in my opinion, they both work hand in hand. If all the computers die, the lights are probably going to go off. But they may not, okay? I mean, we had electricity before we had computers, so, and they managed to keep the lights on then. It's a little bit more difficult nowadays, but it can be done. So you've got a culture clash between the two groups because IT is wanting to approach development and integration and maintenance in a certain way, and the operational groups are saying, you know what, I got to keep the lights on because I'm going to get fired if the lights go out. And trust me, the CEO of ERCOT found that out. When we had a rolling blackout, we had to pick who to take out, and, you know, we picked the legislature because we wanted to keep the hospitals going. That was a big mistake. They got really mad, and they fired the guy. So, yeah, it's kind of important to know how to do this. Then you have the big data issue, the challenge of big data. You've got all this massive data coming at you, and how are you going to turn that into information and use it? CIM will help with that, but it's not the panacea. It's not going to solve the problem. And then you also have all of the normal integration, organizational impacts of integration and re-engineering and restructuring and everything, and change. People don't like change, especially if it means the lights might go out, okay? Okay, so then and then there's the whole issue of retraining. CIM is not going to solve the issue of retraining. It's going to actually make it worse. You have to retrain if you're going to have CIM be operational and functional. People have to start thinking in terms of models. So it's a little different situation. There are some keys to success, however, okay, that we need to look at. Information requirements, okay. The CIM will help you map your enterprise onto a meta model, and that will in turn help you manage that data. It gives you a language that will allow the IT and OT folks to communicate, okay. Information requirements are critical. That's going to, if you define all of the information requirements you have, and you identify them and get that data turned into information, all of a sudden you understand security issues, you understand the meta model of your enterprise, you can communicate with people, and it really helps. So information requirements are important. The enterprise integration environment has got to be defined. You need to choose the right tool chains, and by tool chains I mean in order to integrate, you've got tools. You've got an ESB, you've got modeling tools, you've got, and I say that down here, the information modeling tools. You've got all kinds of tools that you need to be able to achieve the integration, and those tools have to be interoperable. They've got to link together nicely. They have to play nice together, okay? So make sure you choose the right tool chain, make sure you get a solid service bus, you have an adapter framework, and make sure that you have information modeling built into your integration environment. And by that I mean make sure that modeling and all of these tool chains are included in your SDLC, the System Development Lifecycle. Make sure that all the way through you are covered and you have implemented everything, and it all works together, and all the pieces are included, so that whenever you go to do a project or an integration, you can have solid schedules. You've identified all the pieces. You don't have any gaps left over, which gaps are going to cause problems with schedule and they're going to cause pressure, okay? Incremental adoption. Make sure that you do not try and do what ERCOT did. ERCOT tried to integrate 15 different systems all at once, either upgraded new systems or brought in upgraded existing systems or brought in whole new systems and implemented CIM on top of it. We did it, and it worked. Don't get me wrong. It was painful, but it worked. It took longer. It cost more than it should have cost, and it took longer than it should have taken. If you do incremental adoption, you're going to get the highest value first. Identify the low-hanging fruit. Identify what is going to get you the biggest bang for your buck, okay, and what is going to show the rest of the utility or the rest of the enterprise that this is a good thing. It does work. It allows them to accept change slowly and come along with you rather than try and shove it down their throat. And maintain some sort of training strategy. Training is critical. You must train all the way through. And if you're an ISO or you have member companies that you work with or partners, you must make sure that they are trained up with you at the same time, and everyone understands the integration strategy that you're going to do, and all the training is taken care of. So let's talk a little bit more about information requirements. So integration is more than data mapping, okay? It includes the business process. It's not just data. If all you have is data, you're not going to get information out of it. You must understand the business process in terms of actors and the use cases, the life cycle, activity diagrams. What do you need? How is that data used within your system and within your enterprise? Then you can turn that into information. And at that point, it starts getting real exciting, and people start realizing what they can get out of this and how valuable this is, and all of a sudden, they start working with you, okay, which is a lot better than the alternative. So, and then capture your information requirements for each integration point. Make sure that you have modeled your enterprise and that you have a bridge between the data-centric, which is that operational side, and the process-centric, which is the IT side, and the two sides have come together with that bridge. They both understand what they're going to get out of this. They both understand what they need out of this, and your integration and your information requirements are fully defined to make that happen. Okay, the payoff of the integration standards. First off, it defines who needs what, okay? It allows you to gradually get legacy skill sets onto the standard, okay? It allows you to avoid the need for that knowledge transfer about those legacy representations. What you don't want to do is have to have the IT department know every single legacy system out there. You also don't want the bus department, okay, the people who are doing the integration for the ESB to have to know all of that either, okay? The easiest thing to do is to do all that adaptation, but to get some help, okay? If you don't, that is your pitfall, by the way. Got a little bit ahead of myself. So on the bus, you have to have those adaptations. You have to have those transformations that we were talking about from the legacy serialization into the CIM XML, okay? And who builds those adapters can be the possible pitfall, because what usually happens is either the ESB folks have to build those adapters to do that transformation on the bus, or you have the custodians of the legacy applications build those adapters. And what we're saying is it's better to have the people who know those applications, who understand that data, understand how it fits, how it works together to do those adapters, or at least to provide the requirements and everything for a group of IT folks that are only building adapters, okay? Trying to get the bus to take over all of the transformations is a uniquely difficult problem, okay? So don't try that. Also, what are your new skills that you're going to need? To be able to do this, you've got to have information modeling. You've got to have some people either in your integration team that work for the enterprise or on the integration team of the vendor that you've hired to do your integration that knows and understands UML, XML, XSD, and XSLT, and that understand the tool chain that you have selected. Okay, whether that tool chain, now, if you're using the CIM, it's easiest to go with the tool chain we have already picked because we've already put together some free tools for you to make that work. One of those is the Sparks Systems Enterprise Architect. That is the information modeling tool we use. It is one of the cheapest out there, so it's low barrier for entry. CIM Tool is the message noun payload generator we use. It is free, and it works very well and is very well integrated with EA. And then the adapter framework, whether it's JMS or JCA or any of those, you need to select those. But your integration team needs to know all of this stuff. If your vendor that you have purchased your outage management system is also doing the integration and they do not know this stuff, you're going to have a problem. It would be better if you either get your own internal enterprise team that knows this to work with that vendor, or you bring in an integration team that can help do this. So where do you want to start? You want the highest value interfaces, as we said before. Make sure you get the best cost benefit. It's really important that the enterprise and the organizations that are being impacted see as immediate a change that worked, immediate success stories as possible. So try and make that happen. Make sure that you do training, retraining, cross-training. I can't say this enough. Make sure that all of the people involved in the integration, the business side, the IT side, every other side, is involved in this training, that you carry them along with you so that they are all aware of what's happening to them and how it's going to help them, okay, hopefully. And identify areas where it's the most needed. So you've got a regulatory mandate that's going to help you push through this new high-value thing, right? Or you've got customer engagement. You've got a customer that is pushing you to get this new capability because that helps sell management on the budget, okay? But all of this also, if you can enable you've got a problem with the legacy system, and all the people that used to know that system have retired. Now, that didn't used to be a problem, but lately it's happening more and more and more where the people who knew that system are gone, and everybody's afraid to even pull a little thread because everything's going to come apart, okay? So that is a very high-value place that you could start that would help the enterprise, and it would take some stress off some people, and it would be easiest to sell that. So that's how you need to select. Those are the things that you need to do to help you pick where to start. Building out that integration environment. Okay, I'm going to say this. CIM doesn't care which one you use, okay? But what's important here is that you have the ownership of the information, including the people who are in the business processes, the ownership of the technology, are involved in building out that integration environment. They need to invest in that knowledge base around the standards. They need to have ownership of this. Avoid having to grow that knowledge base around the legacy apps. It would be much better if you've got this integration environment properly done, that the integration team doesn't have to know those legacy apps anymore. You've got CIM using it. You've got the Part 100 using the implementation techniques there. Any bus will do as long as it has the capabilities for standard message exchange. I know some utilities that don't even have a message bus. That's fine too. Use what you got if it'll work rather than doing retraining. On the training, I can't say enough about this. Make sure that your training is hands-on and it's in the context of the tool chain you selected. And I mean, get the people in there that are going to be using this in the future and get them using it. Don't just have a training class and walk away, okay? If they're going to have to maintain this stuff and work with it every day, you need to get hands-on. They need to know how to use this. Consultants need to work yourself out of a job. It's okay. They'll call you back, okay? It's important that the enterprise get the hands-on training. It's important that information modeling concepts and the standards themselves be taught to at least the IT or the integration team that is using it, okay? And make sure that you provide all the training for the information requirements for the business processes, what level of security, what are your differentiators, new standards. If you need some, if you've identified something that's missing in the standards that is not a differentiator for you, please submit it as an issue. Get it in front of the standards body so it gets into the next revision, because that way you won't have to pay for that special every single time you do an upgrade to your product, okay? And get training on the adaptation tactics that you're going to use. Identify what they are, work through them, and make sure that everyone on the team knows what they are and is pulling this cart the same way, okay? Then the rest of the program is just, you know, program scope and planning, right? Standards adoption is transformative. Believe me, it's going to change your organization more than the technical stuff that is involved. You've got to change your way of thinking. Investment is very much front-loaded, okay? You've got to find a way to justify the cost of this, but in the long run, it's going to be faster and cheaper. But if you've got a pipeline of projects that you can show quick benefit for, get cumulative value out of, and that sort of thing, make sure you have milestones. Make sure you define success criteria for each of the projects, and each time you move something out of the point-to-point or the legacy integration into this new integration technology. Make sure you define the success criteria. Make sure you have an investment stream, because this is a multi-year effort. One of my standards buddies says this all the time. CIM is not the easiest way to do anything. It's the easiest way to do everything. If you're doing one system integrated to another system for one message, this is going to cost you a fortune, okay? But if you're doing 10 systems over a period of years, and each system has got 10 messages in it, now this is going to be very inexpensive and the cheapest way and the most effective way to go. If you want more information, please call myself, Scott. Let us know. We'll get back with you. In addition, we're going to have a session. We have a CIM University at every single CIM user group, and I present this again there. Our next CIM user group meeting is in Australia in February, the last week of February. Feel free to show up, and I'll meet you, and we can talk. If you've got specific questions or you want to get down into some more details, we can do that. If you can't make that one, we've got another one in June in Norway, and next year we will be back in North America as well. So that's all I have, and if we have any questions, we're open.
All right, thank you, Margaret. We've got two questions. The first is, do you have any recommendations for applying the CIM in a 4-service utility, electric, gas, water, wastewater?
Okay, I let Scott do this. Scott, this is your part. You get to come in and talk now.
All right. Yeah. Well, on that one, okay. Certainly, the Dash 100 applies. It can be very easily applied, whether it's water, gas, electric, whatever. Not a problem. No. The CIM, as far as the payloads now, okay, the CIM, has a good focus on electricity, but it's not as broad of a coverage in a water and gas. It's not its a primary focus for water and gas. But Dash 100 and the integration techniques would apply to all of those. Margaret, you want to add to that?
Yeah, well, we have actually approached IEC about how far can we go into gas and water, because we have a charter within within the IEC that says we must stay with electric. So we have to be careful. We have included some things in some of the Part 9 work, the metering work, to where you could pick a gas meter versus an electric meter or a water meter. But we have to be very careful how deep we go into there. But your integration team could literally use the Part 100 and the messaging philosophies of Working Group 14 to create the messages that they need to integrate the electric and water and gas. Absolutely.
Yeah. That's actually good, Margaret. Good point, Margaret. Yeah, and metering, it doesn't care if it's electric, water, gas, or whatever. It just doesn't care.
Okay. Have you guys considered putting together a return on investment-based business case that utilities might use to convince their execs?
We go into clients all the time. Every utility is a little bit different. We go in, we look at their